Your next challenge in the 7 Caillou series is called Narcissistic Numbers. A narcissistic number is a number of length L in which the sum of its digits to the power of L is equal to the original number. If this seems confusing, refer to the example below with the number 153. You can see that L equals 3 in this case. There are 3 digits in the number. And then if you take 1 cubed plus 5 cubed plus 3 cubed, that sum equals 153, which is the original number. So that's a good example. Write a function that, given n, returns whether or not n is a narcissistic number. Please pause the video, attempt this problem, come on back when you're ready. So to solve this, I'm going to make a helper method that will convert the original input number, n here, which is a long, into a sequence of its digits, because we need to raise each digit to the appropriate power, which is the length of the input number. So to do that, let's go ahead and make another method. And I'll make a private static, and I'm going to do it a little different. We'll just introduce a new concept just because I like to do that, but if you wanted to make this return a list or some other kind of collection, feel free to do it that way. I'm going to make it in IEnumerable of type int, and I'll call this method getDigits, and it will take a long. And we'll sort of use this to pass in our input and get back some, you can think of it like a really generic collection of integers, or I don't even necessarily want to say collection, because you'll see what we do isn't really a collection. Almost like just kind of generates numbers as we need them. So to do that, we've talked about how to get the digits of a number. We've done that before. Hopefully that's familiar to you, but that's why we repeat things too, to get better at it, right? Well, n is greater than 0, right? And the idea is that we can use the modulo operator to sort of peel off the least significant digit at a time. Then we update by dividing the value by 10 each time. So it's kind of like we use that modulo to get the value, and then we divide by 10 to remove it. So the next time we loop through, we're at the next least significant digit. And if you don't remember this, just pick an example. Make a number like 1,953, you know, or whatever you like, and then just step through it one at a time. Take that number, divide by 10 and get the remainder, and you'll see. Do it a number of times until you just believe that it works. So I will say int, the first digit I want is going to be that n modulo 10. But since n is a long here, we'll probably get yelled at for trying to put it into an integer result. So I'm going to use this old C-style cast to just say, hey, this value that you get here, interpret it as an integer. Because it's just one digit, right? A one digit can't possibly go beyond 2.1 billion, you know, outside the range of integer that we saw in a previous video. So integer is plenty big to hold any single digit. So then of course we have to update so we don't loop forever. That's why we divide n by 10 so we make progress. And then the new thing that we can do with this I put IEnumerable. How about IEnumerable? I will say yield return digit. And so this basically tells you to give one digit at a time with this getDigits method, and that's kind of weird, this iterator method, a little bit different, but again, we're just stretching the mind. You don't have to do it this way, but figure let you see something else and start opening your mind to that. But you don't have to take my word for any of this as usual. You can go to the documentation. You can see IEnumerable exposes the enumerator, which supports a simple iteration over a collection of a specified type. We're using the generic one here, so we have this type T. In our case, it's integer, right? So yeah, you can think of this as sort of like this. Remember, we talked about the classes that start with I, right? Like interfaces. Sure enough, interface, right? And so you can think that when you see this IEnumerable or something that implements this IEnumerable, you're guaranteed to have an enumerator associated with it. And when you make your own IEnumerable class, you'll see that you're required to expose the enumerator. You have to make a method that makes that available. I think it's called getEnumerator, very appropriately named. But yeah, feel free to look through the examples if you find that helpful. We're not going to implement extra classes here. We're programming in C#, so we're going to take advantage of that yield keyword that you saw me use before. But you can kind of see how this works. This current property and there's a move next. So you can imagine just starting at the beginning, and you can keep calling move next, and it will keep giving you a value which is stored in this current field one at a time until there are no values left, and then it's done. But you could just keep generating values if you wanted to. So I think that's enough to get us going. What do we have down here? Anything useful? So you see the for each statement works with this. Anything that's IEnumerable you can use with the for each statement. Yeah, the ability to iterate through the collection. Okay, good stuff. So yeah, you can imagine that this is going through the loop one at a time. Give the first digit, give the second digit. And if you remember in past challenges, right, we had the issue where if you're not careful, remember you're getting the digits in the least significant integer first, meaning in the number 153, you're going to get 3 first, then the 5, then the 1, and that's backwards. But for this problem, right, they're just saying add up these exponents, right? You're going to take each value, put it to the appropriate exponent, and then sum them. And we know with addition, it doesn't matter the order you add in, right? So you could switch. You could put the 3 cubed here and the 5 cubed last, or the 1 cubed last. It doesn't matter with addition, right? So even though we're getting the numbers in reverse order, it doesn't really matter. So why do extra work to, put it in the right order when it's not meaningful in any way? So anyway, we have that. Now we can get the digits. I'll call it var digits, and if I haven't shown you the var keyword before, it's just a handy little thing you can use when you don't want to explicitly put the type. We could write out IEnumerable of int, that's more typing. In one sense, it's better because it's more explicit. You can see immediately what it is. But you can use var as well. Nice and short. And if you name your variables well, it's pretty clear what kind of object you're dealing with. So good. At this point, we have the digits, or at least we have. Remember, this is an iterator method. It's going to give us access to that enumerator so we can pull digits when we need them. And that could happen if we used a for each loop. In our case, though, we're going to use it in LINQ, and it's the same kind of thing. We've seen in LINQ how they process one element at a time. So let's get into that now. Let's start working with these digits now that we have them. So we can say return digits, right? And I'm going to use select. Do you remember select? Pretty handy one. We'll go to enumerable if you want to see your LINQ methods. Where's our methods? Here we go. Go down to select. There's a good description there. It projects each element of a sequence into a new form. And that's good, right? Because we have the 1, the 5, the 3. We don't want those. We want 1 to the power of L, 5 to the power of L, or whatever number we're working with. So we want to project our sequence of digits into a new form. Perfect. So let's use select. And then of course we provide a lambda that says how to project. So remember the first part is your argument list, right? With a method. Here's your argument list. Here's your parameter list. So pick a variable name. I'll use num, right? We're dealing with digits that we know are integers. I think num is a good variable name for that, but it's whatever you like. Then we have that arrow that says, hey, the parameter list is done. Now we're moving into the method body, the part between the curly braces and a standard method. And so for that now, we want to raise to the power, right? We've used math_pow and other challenges, right? You provide it a base, which is num, and then you give it the exponent value, which for us would be the length of the input number, right? And do you remember, if you have a IEnumerable, I don't want to necessarily say collection, but like a collection, how do you find out how many elements are in it? Well, you have count. So hopefully you see by now this IEnumerable class, you can just keep this open with all these methods. You'll be scanning them a lot. So count, yeah. In a recent challenge, we did it with a lambda where we counted only elements that met a certain criteria. In this case, though, we just want to count all of them, right? We want to know how many digits there are. So we can keep it simple. We don't need to pass anything to it at all. And it will tell us how many digits were in there. So we can say math, the math class we're invoking, so we'll have to bring in a namespace for that, or bring in a library. Raised to the power base, which is that either the 1, the 5, the 3, right? Your digit number. I suppose I could call it digit, right? That's an even better name. Let's do that. Digit. Cool. So yeah, we raise to the power, whatever the length is. Remember, it's not necessarily cubed, right? It was cubed because 153 was 3 digits long. Our long, could be 5 digits long or more. We don't know. So, and then you can imagine after that, right? Now, with this part here, right, we've transformed the digits, let's say 153, into the powers, 1 cubed plus 5 cubed, and 3 cubed. So that'd be 1 plus 125 plus 27. So those are the values in there now. And what do you want to do with those? Well, it's said to sum. We know that IEnumerable has sum right there, right? So you can use that to add up all your values. And what's the deal? What are you doing with this sum? You're saying if it equals to the original input, right? So we're going to get in trouble here. math_pow. Let me go ahead and bring in definitely, well, let's look it up. System collections generic, right? Let's do that. Using system collections generic. And then we can go C# math_pow. And what do we need to bring in? We need to bring in system, right? Let's do that. Using system. Okay, hopefully, oh, and link, right? Because we're using select. Using system.link. Okay, that should probably cover us. Let's go ahead and hit the test. There's no argument given that corresponds to the required formal parameter n of kata get digits. So let's see what we did. And they're telling us it's the errors on line 9, right? So yeah, there's a problem. Do you see what it is? I called get digits with an empty argument list. And we see that in our sort of contract, the way we think of methods, there is a parameter present. So this is not a match. All bets are off, right? We didn't uphold our end of the deal by providing an input. Now, you can't, this isn't really related to this, but you can set default values, in which case this would work. It's wrong, but you know, it won't blow up saying you can't use get digits this way. But I don't want to use it that way. It should take a number. And I forgot to just pass the input along. So let's do that. Okay, what did we get here? True tests. What did we fail on? What did I do? And okay. Large value. Expected true. Expected this is a narcissistic number, but was false. Digits. Select some digit. Yeah. Some, that looks right. Well, just trying to see here. Oh, you know what I did? That's kind of subtle. I wonder. One thing I'm just not sure about. This cast here is probably just applying to that n. I just want to make sure it applies to the whole quantity. Okay, yeah. So yeah, that was kind of a dirty little bug. You got to be careful though, right? So yeah, without that, it was just casting the long to an integer and then performing the operation. So okay, before we claim victory, I will run the full test, and good, we got the green. So yeah, I hope you found something useful in this. We've used certainly other more concrete collections that implement IEnumerable, so hopefully this wasn't too new, but you could see how we didn't really commit to making a collection, right? Because this was kind of throwaway. We didn't really care about having this 1, this 5, and this 3 in some collection, right? It wasn't going to persist. It wasn't something that we needed to add to and modify over time and maintain and check back on. It was just kind of this throwaway thing. So we don't even bother actually creating a collection. We just kind of make this IEnumerable that is guaranteed to have an enumerator that will run the body here sort of one at a time because of this yield return, right? Did we look at, you can go to the docs for yield return. See, you can use a yield return statement to return each element one at a time. So that's kind of the idea there. If you wanted to break early, you can use yield break. If some condition, imagine we were checking for something and you said that's enough, you wouldn't have to go through the whole sequence. That's handy. And yeah, so we just sort of get them one at a time as we need them to do the work. But it's fine if you made a collection and used that, if you made a list of integers or whatever. And then yeah, pretty much came down to taking that sequence, transforming the digits into applying the powers to them appropriately, adding it all up, compare it to your input. So I think I'll submit mine like this. And then you know what to do. Go through, see what you can learn from other people too. And then, yeah, show me what you came up with in the comments. Otherwise, yeah, come on back for another challenge. We'll keep them rolling. So, thanks for watching.